Well, good morning, everyone. I hope you're all doing well, first of all. I just wanted to take just a minute and explain to you the unit circle. So you're going to be able to you're going to need the unit circle on everything that we do from this point on in our trade course. So understanding the coordinates and the reference angles of the unit circle are going to be very big. Now, first of all, let me explain that what has happened here is that you have a circle with a radius of 1. So every one of these coordinates that I'm highlighting, they all have a part of a circle with a radius of 1. Okay, so you're looking at one unit in the circle. In other words, this coordinate is 1, 0. So when you look at a coordinate plane, this would be inside, this would be the circle is drawn, that would be drawn if you went out to 1, 0, you went up to 1, not 1, 0, 0, 1, you went up to 0, 1. So this coordinate is 0, 1. You went out to negative 1, 0, and you went down to 0, negative 1. Those would be the 4 basic coordinates that you have on what is called the unit circle. It's a circle drawn with a radius of 1. So what that means is every one of these, and I'll highlight them for you. So we're going to say that this one, it has a radius of 1. We'll go with this next one and will be blue. It has a radius of 1. That wasn't a very good one. We'll draw another one. It has a radius of 1. And then let's pick up a green one. This one also has a radius of 1. In other words, the reason it's called a unit circle is every part of this has a radius of 1. Okay, now I need to explain to you the importance of this because it's really kind of cool how this works. Now, if I were to ask you if this were no triangle and it had a radius of 1, then you would be able to find the other trigonometric values according to these coordinates. This is an x, this is a y, and if you use the Pythagorean theorem, 1 squared plus 0 squared is equal to r squared. So you would know that your r is equal to, in this case, let me put the equal to on the other side, that the r is equal to 1. So if I asked you to find the 6 trigonometric values from a degree of 0, it hasn't raised off. So this is my initial side. If I ask you to find the 6 trigonometric values from an x, y, and r of 1, 0, 1, you could find all of the 6 trigonometric values from that way, or from those coordinates. Now, in each one of these units, there are 3 particular degrees that we have to learn. So if this is my initial side, and this is my terminal side, and we move 30 degrees, well, that's going to be really important to us because we're going to have to memorize this unit circle, believe it or not. So if we've moved 30 degrees, and I'll show you what all these lines and things mean around the unit circle in just a minute, but for the teaching purposes, I wanted you to see that if this is our initial side and this is our terminal side, we've created a 30-degree angle. And if I drop a right angle here, using the properties of 30, 60, 90-degree triangles, if I have a radius of 1, that means my hypotenuse is 1. That means the side opposite of the 30-degree angle was x. This was 2x, and this was an x root 3, because this would essentially have to be a 60-degree angle. Now, if I know that the radius of the circle is 1, that gives me the hypotenuse of the reference triangle to be 1. So what I need to know is if 1 is equal to 2x, I'm basically solving a little reference triangle, and I'll just put it over here so you can see it. So there's my 30 degrees. This is 1. I need to know what the other 2 parts are because that's going to tell me what this coordinate is. And I'm going to write that coordinate right here. Okay, so if 1 is equal to 2x, then I need to know what x is. So if I divide that by 2, then the x, which is across from the 30, is equal to 1/2. And if this is 1/2, then the side across from the 60 is 1/2 times the square root of 3, which we're going to call root 3 over 2. Now, if this is my x coordinate and this is my y coordinate, then that means this ordered pair is going to be the square root of 3 for the x over 2, and the y value is going to be 1/2. And so what I'm telling you in this case is that my 30-degree angle will create a reference triangle that has opposite of the 30 as 1/2, opposite of the 60 is root 3 over 2, and then the hypotenuse is always going to be 1. So each one of these, your hypotenuse is always 1. Now we're going to move to the next one. I'm going to change colors. Let's go with blue for this one. Okay. Again, we're going to draw the reference triangle. And instead of me having 30 degrees, now I'm going to go from initial side to terminal side, and this is going to be 45 degrees. So I do have a little reference triangle that I can pick out now. So if I draw that same triangle, but now it's a 45-degree angle, and remember my radius of the circle that we've drawn, the unit circle, is always 1. So remember in a 45-45, both of the two legs have to be the same length. So these were x, and this is equal to x root 2. So what I need to know is what is x. So if I say 1 is equal to x square root of 2, then in order to solve it for x, I need to divide both sides by the square root of 2. And of course that needs to be rationalized. So when I rationalize this, I get the square root of 2 over 2. And both of these have to be the same length. So when I'm referring to a 45-degree reference triangle, I'm going to tell you that this coordinate then, my x is root square root of 2 over 2, and my y is square root of 2 over 2, so that coordinate is square root of 2 over 2. Now, this is kind of nifty how this works. I'll get to the last one. So the last one, let me switch to green. Okay. And again, my radius is still 1, and I'm going to drop my right angle again. But this time, my initial side starts here, and my terminal side ends here. And what I've moved to is a 60-degree reference triangle. All right, so at the top, I'm going to draw a 60-degree reference triangle. And this one is 60 degrees. Again, my radius is 1. This is going to be my 30. So this is my x. This is, remember, equal to 2x. And now this is my x root 3. So what's happened is, if you're paying attention to this, what happened is these two angles have now switched. This was the x, and let me go to red real quick. This was the x, and this was the x root 3. And now what's happened is they flip-flop. So if you're creative, you'll understand that what happens is that these coordinates are going to flip-flop as well. So watch what I'm going to do. So what I'm going to do is just solve this. So I'm going to say 1 is equal to 2x. And to solve it for x, I'm going to divide it by 2. So x now is equal to 1/2, but it's over here. And this one turns into root 3 over 2. So the final coordinate that I have, remember now this is my x and this is my y. So my x coordinate is 1/2 and my y coordinate is the root 3 over 2. Now, the cool thing about this unit circle is that it's the same all the way around. With the exception is you have to pay attention to whether you are moving to the left and up, to the left and down, or if you're moving to the right and down. The reference triangles are all the same. This is what I love about this. Okay, so I'm going to do this one first. So do you see that I have moved to the other side now? And if I drop this angle down, and this is now my initial side, this is my terminal side, that this is a 60-degree angle. I've only moved 30 degrees away from a vertical line. So this one will give me all of the characteristics that I had with this reference triangle of 60 degrees. I'll have a half and a square root of 3 over 2. But remember, you moved left and then you moved up. So my x is negative, my y is positive. I'm going to switch to the blue. So the next one that I have, if this is my initial and this is my terminal, I'm now at a 45-degree reference angle. Now, remember that I'm going backwards, so I'm going to show you the exact angles in just a second. But the reference triangle that I'm working with is a 45-degree one. And if I know what my reference created in the first quadrant, then I'll know what it creates in the second quadrant. And so this ordered pair is a square root of 2 over 2 and the square root of 2 over 2. However, remember that you moved left and up. So this is a negative square root of 2 and a positive square root of 2. And then the last one that we have is here. And if I move from initial to terminal, then this is a 30-degree angle. And if that's a 30-degree angle, then I have the exact same values that I had in the first quadrant, but I've got to remember that I move left and up. So my x-coordinate is root 3 over 2. My y-coordinate is 1/2. But since I moved left and up, my x-coordinate is negative. Now, I've shown you how all of these are in coordination with their reference triangles. However, everything starts from the initial side and then opens up. So this angle that I've referred to as a 60-degree reference triangle is actually not what we're looking at. It's the 90 plus 30 more. So this actual angle is 120 degrees. And then if I move 15 more, it'll make this 45-degree reference angle. So from here to here is 135 degrees. And then if I go from my initial, remember everything is measured from your initial 0 degrees until it opens up. And this one is going to open up then to 15 more degrees. I stopped that first one too early. So this one is the 120. This one is, I have to add 15 more, so 135. And then this last one starts at the initial and ends once I've gone 90 degrees and 60 degrees more, is going to put this one at 180 degrees. Now, I'm going to go back to this side and I'm going to move my references from in here to where I need them to be. So this is a 30-degree reference. The blue triangle is a 45-degree reference. And the green triangle was a 60-degree reference. Now, the final thing that I need to do, well, I'm going to fill in the rest of the circle, and then I'm going to explain to you one final really helpful note. All right, so if I move down to the third quadrant, remember that these are labeled in quadrants. This is your first quadrant. This is your second quadrant. This is your third quadrant. And this is your fourth quadrant. Remember, they're labeled counterclockwise. And always make sure that you use Roman numerals in the counting. Now, if I continue into the third quadrant, then what I'm going to do is I'm going to start at the initial side and I'm going to spin all the way around to here. Now, if you'll pay attention to what we're looking at, let me give you a red. So this angle is following the other red angle over here. So what I know is that this amount is 30 degrees below my 180 degrees. So whereby I'm looking at a 30 degree reference triangle, the actual angle from here all the way around is 180 plus 30. So this is going to be a 210 degree angle. Now I left this one out. This one is 180 degrees. I see I've got a mistake here. 135 plus 15 is definitely not 180 degrees. So let me erase this little piece and then we'll go back and correct that. So 135 plus the 15 more is going to make this one 150 degrees. Sorry about that. Make sure you change that in your notes. Because we know that this one is 180 degrees. Your straight angle is 180 degrees. Then I move 30 more, which makes 210 degrees. And then we'll switch to a different color. So the next one in, so starts here, goes all the way around to here, adds 15 more degrees. So we're using a 45 degree reference triangle. However, if I had 180 and then I had 210 and I added 15 more to it, this one is going to be 225 degrees. But remember, those reference triangles are still the same. So this one back down is 30. Go to the blue one. This one back down is the 45. And then the last one back down, so from here back down, is going to be the exact same angle that you had from here. And let me go to green, which is going to mean that all of these are the same angle as your 60 degree reference. I just have to remember which quadrant I'm in. Now, if I change that, so if I've gone 180 degrees and then I've moved 60 more in, a 180 plus a 60 would make this complete angle 240 degrees where it went from initial to the terminal. So 180 plus the 60 degree more reference gives me 240. Now, here's the lovely part. This is what I like so much. If I can memorize the first quadrant, then I can memorize the entire circle in just a matter of minutes. In other words, if this is my 30 degree reference, then these ordered pair are exactly the same. The square root of 3 over 2, 1/2. But I have to remember that I moved left and down. So I have a negative, negative for both coordinates. If the blue one is my reference to a 45 degree reference triangle, it's coming from here, then my ordered pair are exactly the same. And you can remember that it's a 45-45, so that both of those legs have to be the same. And that's where I get the square root of 2 over 2, the square root of 2 over 2. But if I remember that I'm in the third quadrant, I've gone left and down, so both are negative. And then the last one, remember, is my 60 degree reference. So if my ordered pair are 1/2 root 3 over 2, then I'm going to make sure that I write this is 1/2 root 3 over 2. Now, have you noticed that these two are the same ordered pair, just reversed? So the 30 degree and the 60 degree have the exact same coordinates, but reversed. So my 30 is root 3 over 2, 1/2. My 60 is 1/2 root 3 over 2. Switch them. The 45-45 are both root 2 over 2. Now remember, I've gone left and I've gone down, so these are both negative, negative coordinates. This is awesome. It is so cool to learn how quickly you can memorize. And it's not really memorization as much as hopefully you understand what's happened with this one unit. And this is the only unit that we're going to look at for a while. Now, if I started initial and I went terminal to here, I've gone 270 degrees. The coordinate, we already know, it's a 0, -1. My radius, remember, is still the same. So my R value for each one of these has given you a 1. So if you know what the coordinates are and you wanted to find all of the ordered pair of the 6 trigonometric ratios, you certainly can do that. Here's the X, here's the Y, and the R is always 1 around the unit circle. All right, last quadrant. So now we're in the 4th quadrant. All right, let's start this one with the red also. So the red is going to pass from here over to the other side. So that means we've got a 30-degree reference. There's my 30 degree. And if you want to go backwards, you can know that it's 360 all the way around the circle. And my reference triangle is going to take 30 degrees off of the 360 degrees. So that's going to make this one as 360 degrees. But this one that's gone all the way around and stopped here, it's going to stop right here where this 30 degree. So it's gone all the way around to here. And 360 minus 30 is going to tell me that this is a 330 degree angle. And remember, if I'm now using a 30-degree reference, that my ordered pair are √3/2 and 1/2. And you guessed it, the one in the middle is √2/2 and √2/2. And the 60-degree reference is this one reversed, 1/2 √3/2. However, don't forget that now I'm sitting in the 4th quadrant, and the 4th quadrant would give me a positive X and a negative Y. So with every single one of these, I need to change. That one doesn't really look right. It looks like the square root. Every single one of these still has to have a positive X and a negative Y. Now, you see there's some other little broken lines inside of this unit circle. That is whenever we are going to change to radians. So we're going to be able to do these in both measurements. So there are 2 different kinds. There's degree measures and radian measures. Let me put on these. Let me just go ahead and finish this triangle or this unit circle with blues and reds. So this blue matches this blue, and then the green matches this green. All right, so I know that's quite a colorful unit circle. And if we were in class, I would provide you with 3 different color pens, red, blue, green, and we would have done this to our unit circle ourselves. Now, what I need you to do is to memorize. I didn't write this one in here, so let me make sure I go to red and write this in. This one is our 90 degree. All right, so let me make sure we filled everything in. All right, there's 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270. Now, on the other side, I've gone 270. I've moved in 30 degrees. So this one is a 300. This one moves 15 more. So this one is 315. The next one is 330. And let me make that a little cleaner. This one is 330. And then all the way around the circle stops at 360. Now, what are we going to use this for? Everything. From this point on, you're going to use this unit circle for everything. And we're going to ask you to be able to fill in this unit circle in about 3 minutes. So we'll probably do a quick little timed test I'm not sure how I'll do that yet, but these have always been so much fun to be able to fill in this unit circle really, really quickly. In your AMA class, they're going to require that you know this. So, the last thing I need to teach you is how to know your sine, cosine, tangent really, really quickly. Okay. The cool thing about this unit circle is that it is always in a specific order. All of these ordered pair that you see are always, always, always. And let's see if I can find a decent color here. Let's go with this crazy green. Let's go with orange. Let's go with that. Okay, so let's save that. Let's see if I can do this. They are always in the order of cosine theta, sine theta. So somewhere on your paper, make sure that you remember they are in the order of cosine theta, sine of theta. Your ordered pair are always in the order cosine, sine, which I love. In other words, if I ask you what the sine of 30 degrees is, the exact value, the sine, is the second coordinate, is 1/2. Now, if you pull your calculator up, let's see if I can get the calculator up. I don't know that I can once I folded my screen down. But if you've got your screen or you've got your calculator with you, I've got one with me. So I'm going to turn my calc on. I'm going to go to the sine of 30, and it'll tell you it's 0.5. So this is the coolest thing of everything. Well, no, not the coolest of everything we've done. So the cosine of 30 degrees is √3/2. The sine of 30 degrees is 1/2. And if I move to 45 degrees, the cosine of 45 degrees is √2/2, and the sine of 45 is √2/2. The last part, your cosine, your 60 degrees, your cosine is 1/2, and your sine of 60 is √3/2. Now, you may be asking yourself, well, what about the tangent? Well, what about the tangent? Okay, if you'll remember that this is your x-coordinate and your y-coordinate, so I've got a cosine and a sine, and do you remember how we found our tan of any angle? So our tangent had a specific ratio. It was always a y over an x. That's how we found it. So in order for us to find what the tangent of any of these angles are, I'm going to take the y value, put it over the top of the x value, and I'll have to rationalize it if it needs to be rationalized. I'm going to do the first one. Let's go down to the bottom and we'll pick a couple of these. Now you can go back and forth at your chart right now and look at it. So if I ask you for the sine, and then they've just told you the sine of x, and so they're asking you for the sine of 0 degrees. So you look back at your chart. Remember, they're in the order of cosine, sine. So the sine is 0. So the sine of 0 degrees is 0. The cosine of 0 degrees, remember, is 1. Now the tan, so the tan of 0 degrees, remember, it was the y over the x. So it was a 0/1. And the 0/1 would give you a 0. Now, if I asked you for the cotan, do you see that it would be the reciprocal? So the cotan of theta, in this case, if we took that theta out and we said, hey, well, let's make it be 0 degrees this time. And if I ask you for the cotan of 0 degrees, well, it's going to take the reciprocal of this. And do you see that it would be undefined? So much we're learning today. Now let's go to the 30 degree angle. So if I go to the sine of 30 degrees, well, let's look back. Remember that they're in the order of cosine, sine. So the cosine is √3/2 and the sine is 1/2. So if I wanted the sine of 30 degrees, remember that it was 1/2. And the cosine then was √3/2. And you can go through and do every single one of these as fast as you want. So this is √2/2. This one's root 2 over 2. Now notice I'm saving the tans for just a second. Your cosine, remember, are these two reversed. So if you wanted to look back, or if you needed to look back, the cosine is 1/2 and the sine is root 3 over 2. Remember, their order is cosine sine. So if I'm filling in my 60 degree, this is root 3 over 2, and this one is 1/2, according to what I'm looking at here. Here's the cosine, and here's the sine. Or I'm sorry, here's the cosine, and here's the sine. Now, the last one was 90 degrees, and so if I look at my 90-degree angle, here are my ordered pair. 0, 1. Remember, they're in the order of cosine, sine. So the cosine was 0, and the sine was 1. Now, for each one of these, once I learn the tan values, we can memorize the tan values all the way around as well. All right, so if I go to the 30-degree angle, remember that if I'm going to do the tan of 30 degrees now, then remember that I needed the y over the x. So what I have is 1/2 over square root of 3 over 2. Oh, well, that's that complex fraction, which means I need to rationalize and simplify. It's 1/2 times, take the reciprocal, 2 over root 3. So those two will cancel out, and I'm left with 1 over the root 3, which is root 3 over 3. So I will probably want to memorize that this is root 3 over 3. The next one's pretty easy. My tan of 45 degrees is root 2 over 2 over root 2 over 2, which is 1. And then my cosine, so if I move to my sine of 60 degrees, so my tan of 60 degrees, remember that it's the y over the x, so it is root 3 over 2 over 1/2. And if I simplify that, it is root 3 over 2 times a 2 over 1, and that's fabulous because both of those cancel out, and I'm just left with a root 3. My last one, if I wanted to know what the tan of 90 degrees is, and again, you're welcome to put this in your calculator, everything has to match. So if you do the tan of 90 degrees, remember that it is in the ratio a y over an x, so a 1 over a 0. And you should be able to tell me right away that is undefined. Now, what we need to use this for is in your homework today, they're going to ask you to say, hey, well, what is the cosine of 30 degrees times the sine of another degree or whatever? And we're going to ask you to be able to use this unit circle chart to go back and answer any of those questions. Now, some of you were confused on what our homework was, so I'm going to scroll all the way down to your homework. It'll take me a second to get there because this packet is in note packet first and then homework packet behind it. So here's the book and the homework. Okay, so there's so much stuff in here. So make sure you're reading this. If you need further explanation than what I'm giving, it's all in here. It's all in the book. So I don't know, my internet, something's pretty choppy with this right now. It's not letting me move it very quickly. All right, there's initial and terminal sides and all of those good things and how angles spin as I'm just scrolling through your book. Okay. All right, so let's take a look. So you are going to page 20, I believe is what your note packet said. All right, so today you're on page 20. Okay, let me make sure I'm on the right exercise for you. Okay, so, did I go too far? Here it is, I believe. Yep. Okay. So Let's see where it says page 20 for you. Oh, right here. Open my eyes, I'd see it. Sorry. Okay, so here's what I'm talking about on page 20. Okay, so on page 20, we were asking you to do numbers 27 to 41 odd. Okay, so 27 to 41 odd are these. Okay, and they're asking you to find the 6 trigonometric functions for angles and standard position having the following points on the terminal side. So, for example, number 27. So we're not really going to use the unit circle on this part. We're going to use it on the next part. So this was a negative 3, 4. So you're going to move over negative 3 and up 4. So here's what we've done. We've made a reference triangle. This is negative 3. This is positive 4. And here's our reference angle inside. It says to see examples number 1 and 2 if you need to go back and look in the book. But what I need to know is what's the R value before I tell you what the 6 trigonometric values are. So remember, we have 4 squared plus negative 3 squared is equal to R squared. So I've got a 16 plus a 9, and I hope you don't mind me doing a little of your homework. So this is 25 is R squared, and then so you don't have to do this. Of course, if you remember that this is just a 3, 4, 5 right triangle. Some of us, we have so much going on in our lives right now with this virus that we may have forgotten. So it's okay. Whatever you need to do. So I know that I'm looking at a 3, 4, 5 right triangle. And when they ask me for the sine, cosine, tan, so I'm going to just label these right here. So I'm going to tell you that the sine of theta, cosine of theta, and tan of theta. And then I'm just going to give you, it asks you find the 6 functions, and then we want them to be exact. It's going to ask for exact in most of these. So your sine, remember that your sine of whatever the angle is, and you, again, do it however you want, so many different things. You don't even have to draw the reference triangle anymore if you don't need to. Because they gave you this is the X and this is the Y, and you know that your R was equal to 5. If you remember what your ratios are, that your opposite over hypotenuse was Y over R, hey, go for it. So if you're going for your Y over R, remember that it's a 4 over 5. If you're going for cosine, it's adjacent over hypotenuse, or X over R, so negative 3 over 5. And your tan is opposite over adjacent, which remember is a Y over an X, so it's 4 over negative 3. Then you just need to put in, that's bad, your cosecant of theta. I think my Chromebook is saying you need to be done. So I'll hurry up. Your secant of theta, and then your cotan of theta. You just take the reciprocal of each one of those. So this one's a 5 over 4. Your secant is a 5 over negative 3. And your cotan then is a negative 3 over 4. Now, this is too good of a teaching moment to not say this, so sorry. Bear with me one more minute. Remember, this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Did you notice, let me get a different color, that all of these down here were negative, but you had sine and cosecant that were positive? Do you remember that you are in the second quadrant and that they are all positive in the first? That your sine and cosecant are positive in the second? That your tan and cotan are positive in the third? And then in the fourth quadrant, it's cosine and your secant. that are positive in the fourth. So when you get ready to fill in your final 6 trigonometric values, take a quick look at your signs to make sure that they are matching first, second, third, or fourth quadrant according to your ordered pair, as well as who we know should be positive in the first, who should be positive in the second, who should be positive in the third, and who should be positive in the fourth. Okay, so I got really distracted here about doing your homework. So I'm asking you to do on this page. So you're going to do the 27 through 41. So you've got 27 to 41 odd. And then you have 13 to 25. It says every other odd, EOO. So that means 13, skip 15, then 17, skip 19, then 21, skip 23, and then 25, the ones that are circled. Okay, so what I'm asking you to do with this one, I hate to do any of these because there's so few. So you are welcome to do more if you would like. But I need to look back at that chart and say, well, okay, what was the cosine of 90 degrees? So the cosine of 90 degrees, remember, that's up here. There's where my 90 degree is. The coordinate was 0, 1. Remember, they are in the order of cosine, sine. So the cosine of 90 degrees is 0 plus 3 times the sine of 270 degrees. Well, 270 degrees is right here. So this coordinate would be 0, come on, -1. Oh, we may be, our writing time is out. Okay, let's try this again. No, it wasn't. It wasn't out. Okay. Lord have mercy. All right, so this is 0, -1. All right, so my cosine, this time they're asking me for sine. Remember, it's cosine sine. So this is 3 times -1. All right, now the math is super, super easy once I realize what I'm doing. I'm just going to tell you it's 0 plus 3 times -1, a -3. So this solution is -3. Now, there's a couple others in there if you want to check them. So go ahead, pay attention to whether you're in absolute values down here at the bottom. Everything else is basically the same. Okay, this is a lengthy, lengthy lesson. My apologies to you guys. I'm so sorry that I took that long, but this is a long lesson to explain. Hopefully, it will all go well with you. All right, take care, everyone.